what's the domain and what's the range? Domain represents all the possible values of x, all the possible input values, and range is all the possible output values. So let's write those down. And type again so you guys can read. So domain, all possible values for the independent variable, which is x. All the possible input values, same thing as input. And range is all the possible output values. The values of the dependent variable, which is your y. So we've gone over domain and range a little bit in the previous unit with periodic functions. So it should be something that's somewhat familiar. You don't need to go over it a ton. We'll do an example though, or a couple examples I'll sneak in there. Okay, so let's say we have a quadratic function right here. And the parabola has a vertex of 2, -3. Take a second to write down the domain and range for that function. If it's not a word situation, what will always be the domain for a parabola? Kenzie? Exactly. X is always going to be an element of real numbers because the ends of the quadratic function are going to go outward, right? So we're going to have the same domain for all of them, unless it's a situation where, there's a ball bouncing, for example. The ball's not going to bury itself into the ground and keep going. It's just going to stop at that point. So unless it's a word problem situation, the domain is always going to be x is an element of real numbers such that nothing, right? There's nothing to such that. Just close your bracket. We don't need to say such that anything because our values will keep going forever and ever. The range will depend on the maximum or minimum value. For a quadratic function, you're going to look at whether it opens up or opens down, and whatever the optimal value is, the maximum or the minimum, that's going to be specified in your range. So we start off with r equals y is an element of real numbers such that, what are the limitations on the y values? Do we have a max or a min? We have a minimum, right? The lowest it gets is -3. That's the smallest y value. So we're going to say that y is anything greater than or equal to -3. Y is greater than or equal to the minimum value. When we're stating our range, we put the y value first. And if it's a minimum, it's anything bigger than that. If it's a maximum, it's anything smaller than that. Let's sneak a different type of function in here. This one was quadratic. What's that? Yep. Exponential. Good. It's exponential. You see the horizontal asymptote here? Nothing ever crosses that x-axis. So write down the domain and range for the exponential function that's up there. I don't need to give you any points because it doesn't matter what they are. Right? You know they all have that same horizontal asymptote. function, that's how it goes. X is an element of real numbers. So domain equals the set of values where X is an element of real numbers. End of the story. How about the range? Somebody quiet. Thomas?
Y is an element of real numbers such that y is greater than or equal to 0.
So close to being perfect. Such that y is greater than, you said greater than or equal to 0. Which part would I change?
The equal to.
The equal to, because the asymptote means it's never going to touch that x-axis, right? So it's actually never going to be 0. So it's just greater than 0. Okay, it'll get close to this line, but if you keep cutting it in half, let's say it's half-life this way, or doubling time this way, so it gets smaller and smaller. We're dividing it, go 1/4, 1/16, 1/32, and it keeps going smaller and smaller and smaller. It's never actually going to be 0 in theory, right? So it's going to be greater than 0, but not equal to. Let's look at the other type of function we learned. What are 3 types of functions? We didn't do linear up here, but that's fine. Quadratic, exponential, and what do we just do? Periodic. So let's throw a periodic function at the ellipse. Let's do a sinusoidal curve. How about, let's go with this. Actually, I'm going to move it over. Sorry, guys. Make it a little bit easier. You good? Write down your domain and range. Look periodic and I'll put sine or sinusoidal in brackets. Write down your domain and range for that sine curve. What's the domain? Yep. It is. X is an element of real numbers. How about the range? Yep, okay.
Y is an element of real numbers. The -1.
Such that?
Such that -1 is less than or equal to y. That is less than equal to the 1.
Perfect. So for a sinusoidal function, this is the minimum, this is the maximum. And those are the restrictions on our range. Any questions about domain and range? Good. Alright, graphing a linear equation, a real quick review because we only did this for about 2 minutes. I'm going to input, actually we'll sketch it. That's fine. So if I gave you the example, let's say y equals 2x plus 3. How do you graph a line? Where do you begin? Hand up. Oh, Lauren? Good. So we start at 3. Start at 3, which is the y-intercept. How do we move? Perfect. Flip them upside down. Rise over button. So we go up 2 and over 1. So go up 2 over 1. Okay, so I'd start at positive 3. 1, 2, 3, right there. And then we go up 2 over 1. Up 2 over 1. Backwards to make a nice straight line. Domain and range for this line? A linear function, what is always going to be? X and Y are both